Here's another example of finding a 3 by 3 inverse. So here we have a matrix times another matrix equals the identity. So we know that they have to be inverses. So when we want to find the inverse, we want to set up the original matrix followed by the identity matrix. And solve this using elementary row operations. So I like adding multiples of the first row to the third row to the other two. So I'm going to take twice it and add to the first row, and just 1 times it and add it to the second row. And that will give us 0, -6. This will become 12 minus 1, 1, 0, 2. Here, we will be adding 1 copy of it. So 0, -1, 6 times, or 6 plus -4 is 2, 0, 1, 1, 1, 0, 6, 0, 0, 1. All right, now we should be able to simplify this to be nice, these first 2 rows. Taking -6 times this row, -6 times this row, if I get one of these to be 0, then we'll be pretty set. So -6 times the second row, add that to the first row. And let's do that. 0, 0. So -6 times 2 is -12, plus 11 is -1. And then we'll have 1, -6, and -4. 0, -1, 2, 0, 1, 1, 0, 6, 0, 0, 1. Now, let's see. Oh, we can add multiples of the first row to the other 2 rows. So if I add 2 times row 1 to the second row, that'll be nice, because then this will become 0. If I add 6 times the first row to the third row, that'll be nice as well. So now we have 0, 0, -1, 1, -6, -4. I'm taking 2 times the first row and adding it to the second row. So 2 times this -1, adding it to +2. 2 times 1 gives us 2. 2 times -6 is -12. Adding that to 1 is -11. 2 times this -4 is -8. Adding that to 1 gives us -7. And now we're taking 6 times the first row and adding it to the third row. So -1 times 6 will give us -6, plus 6 is 0. 6 gets added there, -36 here, and -24, -23. I want to divide the first 2 rows by -1. So now 0, 0, 1, -1, 6, 4, 0, 1, 0, -2, 11, 7, 1, 0, 0, 6, -36, -23. And lastly, if we switch the first and third rows, that will make the matrix on the left the identity matrix. So I'm going to write down the third row. Then leave the second row the same. And then write down the first row. And that's how we find a matrix inverse.